Hi again, folks. We're continuing polygons. Now we're looking at special types of polygons. We classified polygons based on their regularity. We said that if something is regular, that means that all of the angles and all of the sides, all of the angle measurements and all the sides of the polygon are equal. Doesn't matter what size it is, they're all equal. So for a triangle, that's a 60, 60, 60, or if it's a rectangle, then it has to be a square. So all of the sides are the same and all of the angles are the same. So let's say I have well, it doesn't quite look like a square. Let's say that these are all right angles, and let's say that these are all the same length. Let's say they're all 2. So that means that all of the angles, so this is 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, and you get the idea. Okay, they're all 90-degree angles, and all of the sides are 2. So this would also be 2, and 2, and 2. And for a polygon whose angles are all the same, so either regular or equal angular, so for regular or equal angular, and usually we're only dealing with regular polygons, angular. The sum of all of the interior angles, that is an angle on the inside of a polygon. So this would be an interior angle, interior, follows this pattern, and this pattern is that, well, I'll just give it to you. It's n minus 2 times 180. And where this comes from is actually from a triangle, and I'll show you an example of that. But this is true where n is the number of vertices you have. N is the number of vertices in the polygon. N minus 2 times 180. So for a quadrilateral, I'd say that, well, this has 4 sides, right? 4 sides in a quadrilateral, so I'd say that this is 4 minus 2 times 180. Okay, again, that's coming from right there. So I have 4 vertices in this polygon, 1, 2, 3, 4. So I'm going to take that, I'm going to subtract 2, and I'm going to get 180. Well, 4 minus 2 gives me 2 times 180, which is 360 degrees. 360 degrees. And indeed, 90 plus 90 plus 90 plus 90 is 360 degrees. Or you can just think about the fact that a square is really 2 triangles. And we know that triangles always add up. The interior angles of triangles always add up to 180. So that's like saying I've got one triangle that looks like this, and I've got another triangle right there that looks like that. They're each 180. So this would contribute 180 degrees to the total. This would contribute 180 degrees to the total. So you could always break up polygons based on how many triangles they make, and you know the triangles always equal 180 degrees for the measurements, the sum of the measurements of their interior angles. And one of the things we talked about in class, we set up that chart and we said, well, if you've got a triangle, that's 3 sides, that's 180 degrees. If you've got a quadrilateral that's got 4 sides, that's 360 degrees. Okay. Here, if you've got a pentagon, you can actually take the pentagon. Let's zoom in here a little bit on that. Let's take the pentagon and let's divide it into triangles. You can make this triangle here, that triangle there, that's going to attribute 180 degrees. And you've got this triangle here, that's going to contribute 180 degrees. And you've got this triangle right here in the middle, that's also going to contribute 180 degrees. So that's 180 times 3, 1, 2, 3. And so that's going to follow, it's going to follow our pattern. If we did that, we'd say, well, this is n is 5 in this case. So This would be 5 minus 2 times 180. Well, there'd be 3. That'd be 3 triangles that I divided into. And 3 times 180 is 540 degrees, or 180 plus 180 plus 180. So the sum of all of the interior angles, if you broke it into triangles, would be 540. Okay, this triangle here, and this triangle here, each contributing 180 degrees to the total for 540. The same thing holds true for a hexagon. You can just keep breaking them into successively more triangles, and each time you add a side, so this went from a 3-sided figure to a 4-sided figure, well, I went up by 180. I went from a 4-sided to a 5-sided, and it went up by another 180. So this is the pattern you want to remember here. N minus 2 times 180. N minus 2 times 180. So the sum of the interior angles of a regular or an equilateral, but really a regular polygon, follows the pattern that we just saw because we're broken into a triangle, is calculated by, so follows n minus 2. You take the number of vertices you have, subtract 2 from it, and that equals 180 degrees. So that's the major idea. If you need to find what all of the interior angles of a polygon add up to, you take the number of vertices you have, that's n, you subtract 2 from it, and then you multiply that by 180.